so don't say anything you don't want to be recorded, and that's good. Okay, so let's begin then, and I am going to share with you my plan for this class, and this is going to be a PowerPoint type thing. So I'm here, and this is February the 1st, and go all the way back to the beginning of this. And so we're kind of here, but here's the plan, okay? All right, so this is what I plan to do. I am going to share good news with you, and I'm also going to share news that I call it other news. I'm not calling it bad news, it's just news. So that's going to be the first part, but I think it's important for us to talk about this, so we will. Then I will do some polling, and that means I'll look at the class roster and I'm going to ask each of you actually in turn, do you have anything you want to share with the class or share with me, or questions, or just anything that's going on with you? And certainly I'm concerned. Or when I say concerned, I hope that everybody is doing well. So that's going to be it. So there will be this polling thing that will happen. And then after that, I will turn myself to, I sometimes fancy that Jesse Hayes Carver and I are the pilots of this vessel, and you guys are passengers on this vessel, and we're trying to land the whole thing safely at our destination, and so on and so forth. So I'll just talk about, well, where are we, and so on and so forth, like that. And then we will do some legitimate content today. We'll do some problems and things like that. I'll also make comments about LSAs 1 and 2. And then actually, that last thing doesn't apply to us. I was copying some other things, so I'm just going to erase that because that doesn't need to be there. Okay, so that is then the plan. So I'm going to wade into the good news. Now, this was an email that I found yesterday morning before 8 a.m. And in fact, after I found this email, I was out walking in the hall with my mask on, and I ran into Dr. Caputo, who's the president of our school, who sent this note, and I told Brian I was really excited about this happening. So, this is good. So anyway, I just will read it to you. So this came from the president of the college, and it actually did not go to you, but it went to everybody else that works at the college, and including the board of trustees. Anyway, over the past several days, the COVID-19 indicators have moved in an encouraging direction. And this is certainly true in Illinois. Based on the trends, the college will resume regular in-person instruction on February the 7th. Now, some of you might be saying, well, that was a plan all along. Yeah, but a lot of people at the college were saying, are we really going to do this? Are we going to, do something else? But this is confirmation that this is what I'm characterizing as being good news. And of course, Brian says what we all feel. Our objective remains to keep the college community as healthy and safe as reasonably possible. We will continue to monitor environmental conditions and plan future actions with that objective in mind. Now, what that means for you is that although we will meet one more time in this remote mode on February the 8th for this class, we will be meeting in the classroom, and that's what you should plan on doing. And so that's this for me is good news, and I hope you find it that way as well, because you signed up for a face-to-face course, and it'll be good if you got the face-to-face course. Okay, now I have to go to, I call it other news. And so apparently you've been getting emails about this. Now, this was an email that I got, and I got it about an hour after I got Brian's good news email. And what Diana Del Rosario sent to me, and she is the assistant provost at this school. And she sent it to, well, she sent it to me and other people, but this was not necessarily the letter that was sent to you, but she's kind of saying, hey, we sent letters to the students. So anyway, I will read this again too, also for you. Okay, the message below was sent to students registered for the spring 2022. That means you did get an email, or you should have gotten an email that says this. And not all the students, but students who are registered for face-to-face and hybrid courses that start on February 7th. That's the Monday, and we meet on Tuesday and Thursday, so or February 8th. But anyway, reminding them of how to get ready to be in compliance with the COVID vaccination or testing requirements ahead in upcoming on campus next week. Okay, now that means that you can be in compliance or not in compliance. So you want to understand what that means. And I will talk about, sort of what that means, but you should understand that. And this next paragraph says, these messages are being sent by the Dean of Students. This is Natania Montez. She is a friend of mine. And they sent contact information and links to processes that were being used. Now, the thing that you want to make sure that you understand is students who are not in compliance, not cleared to be on campus as a result of not loading their vaccination card and or the completion of the form that goes with it, or not completing shield testing on campus, are encouraged to visit the student vaccination compliant page on our website. There's the link for it. And they can receive support through Montez's, Nathaniel Montez's office, and then Diane Del Rosario was just telling us about this. And I don't know if I like the way she wrote it, and I'm not disagreeing or criticizing her English, but it was kind of confusing. So I'm just going to say, the College of DuPage says there's a bunch of ways that you can continue to go to face-to-face classes. And one of them is they have on record documented a vaccination status saying that you are vaccinated. So that is one mechanism. Now, they don't say that you have to be vaccinated, but if you're not vaccinated, you have to undergo weekly testing to make sure you're not carrying the COVID stuff with you. And there is a room here at the College of DuPage where you can get tested for free, and it's in SRC 2800. So anyway, this is news that we have now. And continuing then, there are, and this is just taken from the main Blackboard page, but there's a video, this little video, if you watch it, I'm not going to show it to you, but and this is the governor's orders, so if you want to, you can go there and watch this video. It's a video, Nathania Montez is the one who is speaking on the video, and she talks about what you can do and things like that. And it's not just that, but then I also got, this is another thing that was posted, and it talks about, oh, you have to be fully vaccinated or tested weekly, and testing is required in and testing is required for students who are not fully vaccinated. You have to do this weekly. And it just goes on and on and on and talks about all of that. Okay, and then I got another email yesterday at 5. There are a lot of people spending a lot of time at the college doing this, but then they said, oh, there is a new tool. And the new tool is, in fact, let's see. I may go bouncing back and forth, and I'm going to pause for questions if students have questions on this. But students can check cleared or not cleared status in My Access. And so you can go to your student, well, you can go, let's see. Students are now able to check their status under academic profile, under My Profile. So you can go to My Access and you can check that, and you can see what is your status. And you can see that here's 2 examples of, I think these are hypothetical students for sure, John Doe and, these are two students, both named John Doe, but they have different student IDs. And so one John Doe on the left side is not cleared, and the John Doe on the right side is cleared. Okay, so anyway, you can check this yourself. Now, oops, I need to go back. Now, this is an email that, or these are emails and things like that. I mean, people are spending a lot of time and energy doing this, and they're changing things a little bit along the way. But they've also shared with me, and I'm not sharing this with you, but they gave me forms that I'm supposed to hand out to students who are not cleared. Now, what I'm talking to you about now is this little red thing, what Jim plans to do. Because I actually thought about this, and suppose I have a hypothetical John Doe in my class who is not cleared. I don't want to embarrass John Doe by going up and handing him a piece of paper and everybody says, oh God, John Doe is, something's wrong with John Doe. And so I don't want to do that. So what I'm going to do is I'm going to, the next time we meet, and I don't want to spend a lot of time in class doing this. So what I'm going to do is I am going to pass out these to everybody in the class. So before I teach you on February the 8th, I will go to the roster and I'll check and see who is cleared and who is not cleared. And I will hand back or hand out, pieces of paper to everybody. And it will be good because I'll just go down the roster and I'll say John Doe, and John Doe will raise his hand, and I will go and I will hand him his piece of paper. Now, on the piece of paper, I will say clearly, you are cleared or you are not cleared. But that way, you see, I'm doing what the college wants me to do. I'm letting the not cleared students know. I'm also letting the cleared students know. And so, you can fix things if you need to fix things in the wake of that. Okay, so those are kind of the terms and conditions, and I'm just going back to, whoops, back here. And what I want to do is pause and find out if any students, in fact, I'm going to stop sharing for a moment. And I'm going to, okay, so I stopped sharing. That means I can go back to here. And I think what I'm going to do is I'm going to move directly into my polling of people, which means I'll look at the list of students who are in class right now, according to my list. And I'm just going to go down. I think these are alphabetical in terms of first name. I'm not 100% sure, but I think that's what they are. So anyway, I'm just going to go down and I'm going to call on you. And I want to ask you a couple of questions. First of all, I do care about your well-being, and so I'm asking, hey, how are you and yours? Are you guys okay? And I'm hoping the answer is okay, and you can share what you want. But then the other thing is I want to ask, do you have any questions, not just about what we were talking about there, but about the course so far, or just anything that is on your mind. So everybody will get a turn here. And if you're having technical difficulties, you can respond with, what is that called? I guess it's called chat. You can use the chat, but if you want to go on mic and talk to me, that's fine as well. Okay, so my first student here in this list is Denia Safdar. And so how are you and yours? And do you have any questions or issues you want to raise about the class right now, with your classmates and with me here?
No, I have no questions right now.
Okay, and I'm hoping you're all good. Okay,
I'm
so that
good.
is, and again, the questions are always welcome, not only from that student, but from any student. But this is a prime opportunity. I want to really go through this. Okay, my next student is Ethan. He is the only Ethan here. So Ethan, how are you and yours? And do you have any questions you want to ask about things?
I'm all good. I don't have any questions.
All right, excellent. Thank you, Ethan. Fauzan, you were next. And Fauzan answered to everybody just with the text thing, and that's fine. Let's see. Hamza is next. And sometimes students have, technical difficulties, or sometimes they don't want to speak or something, and that's all fine. So Hamza, I'm not hearing from you yet. So yes, I think Hamza fixed the mic or something. So Hamza, how are you, and do you have any questions? And I'm still not hearing anything. Feel free to use the chat if you want. No questions. Okay, that is fine. Isra, how are you and yours? And do you have any questions you wish to ask? And please understand, I'm fine with you asking questions. That's useful.
I'm good, thank you, and I don't have any questions.
All right, so that is fine. And that's good, because I thought that stuff was complicated, but maybe it's not. Maybe you understand that better than I do anyway. Okay, I think it is J-A-E. You are next. So how are you and yours? And do you have any questions, Jay?
Hello, I'm doing great and I don't have any questions.
All right, that is good. Thank you. We will go now to Johnny. Wow, let me try to say this. Hold on. Shirael. And I will probably just call you Johnny. But Johnny, how are you and yours? And do you have any questions, or is everything good? And sometimes you have mic problems and stuff, so feel free to go to use the chat if that's the best way for you to respond. You don't sound weird. You just there was no audio coming from you. So, but all right. So you did ask a question there. Do you have any questions you want to ask? And you could try your mic again if you want. And sometimes what students have to do is log out and log back in to make things work. And I know about that, and that's one of the reasons I would. Okay, so no additional questions. That's one of the reasons I asked Madeline. And Madeline, it is your turn now to ask questions. And I want Madeline to know that I do appreciate her serving as kind of a conscious for me.
Okay, I just want to know, is there like a Pearson's for the homework, or because I missed last class, I just want to know how we would find out about the homework.
Well, okay. And you've asked a little bit of a deep question. There is not a homework assignment thing where you go, there's not like a My Math Lab kind of thing where you go to do things. But there are problems in the book, and I encourage you and all the students to do as many of those problems as you can. But as far as grading, and I encourage you to do as many of those problems as you can, because that is how you get good at your at tradecraft and things like that. You get good by doing problems and things like that. So there's a whole bunch of problems in the book. I will ask you to turn in, and I will grade things called low stakes assessments. And so far there's low stakes assessment 1 and 2. I'm going to be talking about those again today, later on in the period. So Madeline, you don't have to worry. I mean, you will be all caught up with that. The last thing I'm going to say relative to that is Jesse Hayes Carver, and I sponsor guided study groups. And when Jesse Hayes Carver has the guided study groups, you can go in there and ask questions that you've uncovered on your own, including the LSAs. Or if you go in there without questions, Jesse Hayes Carver often comes in
So
with questions.
like the only mandatory homework's the LSAs?
Correct. That's the only homework that will be graded. But I do encourage you to do as many problems as you can and to read the examples. But yes, you are correct, Madeline. Anything else? Okay, you can submit the LSAs. I'll have a spot online where you can submit them. Or to tell you the truth, what's really going to happen is we're going to be meeting in class, so you can just bring them to class as well. And so, and I might not have a place for you to submit them yet, but they're not due until, in fact, for this class, I think really I'm going to make the due date February the 8th instead of February the 7th, just so students can bring them to class on February the 8th. Okay, Matthew Steger, how are you and yours? And do you have any questions you want to ask of me or concerns you want to share with your classmates? Okay, he is good, I guess. Yes, I'm going to make them do, I know, I'm going to make LSA 1 due on the 8th, and the other one I'm going to make due on probably the 15th, whatever's 1 week from that. But we'll say more about that later, but yes. Okay, Michael Lizzer, please, how are you?
I'm good.
Okay, so
I just had
any
a question about,
questions?
yeah, I was just about to ask if we can bring the LSA number 1 to class, and you just answered
Yes, you
it,
can.
so.
Yes, you can. And that's a little bit easier, I guess, because you don't have to, make a photocopy and fax it or do whatever you are doing there. Okay, so that is good. Omar, do you have any questions, and how are you? You doing okay?
Hi, yeah, I'm doing good. I had a question about how the course, like the in-class lectures and the supplemental notes are moving in terms of the book, because I know that you said we start out with actually like chapter 2 and then go back to 1. So whenever I'm like doing the notes, I kind of just get confused in terms of the book.
Well, I think I'll tell you what I will do. Now, I'm not going to do this right now because I want to hear everybody's questions, but I'm making a note. I am going to tell you where we are in the book, okay? And I think we're somewhere in chapter 2, but I'll say more about that, Omar. And if you have your book, then you'll be in good shape to understand that. So, and I have the book here somewhere. I need to look across here. I think, yes, I have the book just under the layer, so I'll be able to. In fact, let me answer that right now, just because you ask. Okay. And I am talking about sort of where I am. So we have talked about all of chapter 1 in your book called Sets and Logic, because I've lectured on sets and logic all throughout there. And that's been some of the, YouTube lectures that I've lectured and things that we do. And we're going to do some more set problems today. But as far as my head, I say, no, we've really done that. And as I look at this, we're also in the midst of being finished with chapter 2. So I will say that we're pretty much finished with chapter 1 and 2 so far. Now that's where I am. That doesn't mean that everybody's in exactly the same place, and I realize everybody got COVID crap that they're doing and things like that. but that's pretty much where I am. Now today I'm going to be talking about set questions, and I'm also going to be talking about some more math induction things, and that's chapter 2. But chapter 1 and chapter 2 in the book really are covered. So that's my that's sort of my answer to that question that you asked. We are probably going to be slowing down in a sense, and that's getting a little bit into my cockpit commentary. I think we are reaching, you see, when you're taking off, there's a lot of things that happen when you're taking off, but then you reach a cruising altitude and speed, and I think that's where we are. In fact, maybe that's my cockpit summary already. We're pretty much at cruising altitude and speed. So Omer, I hope that answered your question.
Yeah, it did. Okay, so for
Chapters
one and we should be done with, so that includes the supplemental lectures, right?
Yeah, and when you say supplemental lectures, maybe what you mean by that is those are lectures that I'm, pointing you at YouTube. That includes them, yes.
Correct, yeah.
Okay. Okay. All right. That's good. And in fact, I'm going to say that, and I'm not arguing with you, but sometimes people say supplemental. That means, oh, it doesn't matter. I consider those to matter. So I do encourage you to watch those as active learners, because I think whenever I'm just thinking about this course, I say, oh yeah, and I've done that. Okay. In fact, I had to think this morning. I said, because I'm going to talk some about set theory in the class today, and I was thinking, gee, do I have to lecture set theory, or have I already done that? And I have already done that. I did that in some of the lectures that I posted there that, we were talking about as being supplemental lectures. So, and we'll do some problems today with set theory, and we'll also do some more induction. Okay, I'm moving on now to Sarah. And Sarah, do you have any, first of all, how are you and yours? And do you have any questions you want to raise with me or with the group?
Hi, we are all good here, and no, I don't have any questions. Thanks.
Okay, well, of course, your questions and anybody's questions are always welcome, but that's good. Okay, now we're going to Suleiman Ahmed, and I'm asking, how are you? And do you have any questions for me, or the things you want to share with me in the class?
No, I don't have any questions. I'm good. Thank you.
All right, excellent. I will go on to Taha. And Taha, how are you and yours? And do you have anything you want to raise with the class?
No, I think I'm all good. I'm doing good as well. Thank you.
All right, that is good. We now will move on to Timothy. And Timothy, how are you and yours? And he is good and no questions. He responded in the text box, which is fine. And Yasmin, how are you and yours? And do you have any questions you want to ask of me in this class? Okay, so maybe that's Yasmin who said she was good. No, that was Timothy. So Yasmin, are you okay? And let's see, she is good, thank you. Okay, so that is fine. And now I'm going back to the list of students because she was not the last. We have Yusuf. Yusuf, how are you and yours? And do you have any questions with the students? And Yusuf is the last student here, so that's fine.
Yes, I'm doing good, and I don't have any questions right now.
Okay, excellent. So, all right, so that's the polling. So now I'm going back, and I am going to be sharing the application screen yet again. So you're going to be looking at PowerPoint slides, I guess, and I have to find the one I want. It is this one. And so you're looking at that, and here's a problem for you. Okay, so, and I think I'm going to give you 5 minutes to do this problem just to see how you do. And if you feel good about this problem, that probably means you feel good about things. So anyway, the question is, which of these which of these sets are equal? Okay, so everybody do this. I'm watching the clock, and at 1:36 by my thing, we'll call time and see how you did. So everybody give this a go with your pencil and paper, think through it, and then we'll compare notes. Okay, I might not be giving you as much time as I said, but let's just wade into this anyway. Okay, let's deal with those 4 sets that are on the end over there on the right-hand side of this chart. You see set E and F are definitely equal because they have the same elements. Now, some students might say, oh yes, but F has 1 listed twice. Well, it's listed twice, but it's only in there once. And so so E and F are equal. And also G and H are equal because they have the same elements. Now, when I start looking at the other sets, and those, that's what we call the roster method, where we just list the elements. But then we start looking at these, and we can find that A, the coefficients add up to 1 there, or excuse me, the coefficients add up to 0, which means 1 is a root. And let's see, 1 is a root, and let's see, the other, if I factor that, that's 1 and 3. So A is also equal to G. Okay, because 1 and 3 are solutions there, and B is 1 and 2 if I factor that. So this is equal to B. And let's talk about C and D. So C is the set of X where X is a natural number and X is odd, and that's going to be G, and H is going to be C. And okay, so D, we get G is 3 and 1. Let's see, what did I do? Okay, 3 and 1 is less than 5, and so that is also equal to D. C, wait, C is, no, I put C in the wrong place. C is up here at the top. I think someone was commenting and I screwed that up. This is C. And I will check the comment in a moment just to see, but then that means that D is down here. Again, it doesn't have to be, but it is D. Okay, so that was a little bit of a review of set theory just to do this. I'm going to stop sharing just for a moment and go look at a comment that might have been made. And the question was, is C included, is 3 included for C? Let me go back and look at the problem then. Should we know that the domain in natural numbers, or is that specified? You should know that the natural numbers are 1, 2, 3, and so on. And the reason you should know that is because we've sort of covered it. Now, I'm not being mean with my comment. I'm just saying that, yes, you're supposed to know that. And in fact, there's a lot of knowledge that we'll have here. So I'm going back and I'm sharing then the thing. And I think Matthew asked a question that maybe has been answered about C, but let's go and look at C. So I'm going back to the thing again, and okay, so here we are. No, this says that X is strictly less than 3. Okay, so X is less than 3, and that means it has to be just 1 and 2. So I think I'm in the right place. And Matthew might have been asking his question when I had it in the wrong place. But anyway, that's what we got, and I think that's more than enough talking about that problem. Let's go look at another problem. Which of the sets can equal a set X under each of the conditions? Now there's a whole bunch of notation here and things like that. And so I think we'll just talk through this. I think it would be very choppy, although this is actually what I like to do in class. I like to give you a problem and say, hey, everybody work on this for a little bit, and then we'll talk through it. And I really would like for you to be able to work in groups, and I don't know if we're going to be able to do that or not with COVID constraints, but we'll see. Okay, first of all, X and B are disjoint. Well, disjoint sets don't have anything in common, and so C is, okay, so this is the answer to part A. It's not A, and B is identical with B, but C is disjoint, and D is not. That was supposed to be C. D is not because they have 4 in common, and E is. So there are 2 sets that could be there, C and E. Now the second one says that X is contained in D. X is a subset of D, but X is not a proper subset of, that means proper subset of B. Okay, so the only answer to that is going to be E. Okay, because E is definitely a subset of D, but B is not, E is not a subset or proper subset or any kind of subset of B. Okay, so that's what we have. Let's go to part C. So we're looking at something that's a subset of A, but not a proper subset of C. So the only answer to that is E also, because now all of these are subsets of A, but means and, so I need to have a proper subset of C. And a proper subset of C says I have the odd numbers only, and it is a proper subset, so it's not all of C, so that is E again. And then we have D here, and let's see, I want to be a subset of C, so these are odd numbers, but not a proper subset of A. I think that is the null set. Because X is So to be a subset of C, it means it has to have only the odd integers. That means the only choice is E, but E is a proper subset of A, and so none of these sets are there. So the null set is the only one. And I guess we could say I guess we could say the null set, but maybe I would say this a different way. I would say that none of these. Okay, so there's nothing between A, B, C, and D, and E that satisfy that. Okay, I'm going to pause and count to 10 Mississippi in case somebody wants to ask a question about that. And if they don't, then we'll go on. Okay, no one asked questions, so, and that can be fine. Okay, let's go to another one. Now, this one, I'm just going to talk through this one a little bit, but it's important that people know how to prove theorems, and this is actually proving a theorem about set theory. And again, I talked about this, and there's a whole bunch of exercises in the book, and things like that for you to do. But okay, so the following are equivalent. Now that means that, so you got three statements here, and it says they're equivalent. And so what we're saying is that A is a subset of B. That means if X is an element of A, then X is an element of B. And the next one says A intersect B is equal to A. And the next one says A union B is equal to B. Now these are all three equivalent. So that means if I assume the first one, I can show that the second one is true. If I assume the second one, I can show the third one is true. And if I assume the third one, I can show the first one is true. Okay, so suppose we're assuming the first one is true. Let X be a subset of B. And we pick X an element of A. Then X is an element of B because that's what it means to be a subset. Hence, X is in A and X is in B, so X is in A intersect B. And since A is a subset of A intersect B, because we started with X an element of A and we saw that it was in the intersection, and so we've shown that this one is true. Now you want to think through that, and some of this proof stuff is a little subtle, but that's what happens. Okay, so now suppose that A intersect B is equal to A, so it is up here, and we pick X an element of A. Well, then X is in A intersect B because those two sets are equal. And hence, X is an element of A and X is an element of B. Therefore, A is a subset of B because we picked X an element of A and we showed it had to be an element of B. And so both results show that A is a subset of B is equivalent to A intersect B equal A. Finally, we go to this one and we show A is a subset of B. Then that means X is A or B because this is or. So X is an element of A or X is an element of B. But if X is an element of B, then if X is an element of A and A is a subset of B, then X is an element of B. And so in either case, X is an element of B, so that means that A union B is a subset of B. Now, to show these two things are equal, you have to go the other way. But by theorem, we learned that the union is contained in A union B, and therefore we show it the other way. And so what we have is that all of these are equivalent. So anyway, those are proofs. And again, we covered some of the material that we covered before, but to show two sets are equal, you have to show that they're subsets of each other. Okay, here is one other example. This is a logic question, but it says, determine the validity of all my friends are musicians. That's statement one. Statement two, John is my friend. Statement three is none of my neighbors are musicians. Therefore, can we conclude that John is not my neighbor? Well, an easy way to do this is to draw what's called Euler diagrams. and you can draw a picture of your friends, and all your friends are musicians. That means the circle, or that's an ellipse, I guess, but the ellipse of friends is contained within the musicians. And John is your friend, so he sits in this circle right here. But none of your neighbors are musicians. That means that your neighbors are over here and they are disjoint with a set of musicians. And therefore you conclude, since John has to be over here, he is not in the set of neighbors. I'm going to count to 5 Mississippi in case somebody wants to talk about that, and maybe they don't. Okay, let's go to another. Oops, I may have heard something. Hold on. So I'm stopping sharing, and I need to go back to this thing, and I'll see if I have a different comment. I think this is not a question, it's just kind of a comment. It says it's too bad if your neighbors aren't your friends or something. I think that's what's being said here, which is I in fact tell my daughter frequently that it is good to have friends. Okay, so we're going back to here, and here's a problem that I am going to ask you to do, and I'm going to give you 5 minutes to do it. Now this is using Venn diagrams. Okay. I am going to give you 5 minutes to do it whenever we start this, and I've got a clock I'm going to be looking at. And so in a survey of 120 people, it was found that 65 read Newsweek magazines, 45 read Time, 42 read Fortune, 8 read all three, 20 read both Newsweek and Time, 25 read both Newsweek and Fortune, and 15 read both Time and Fortune. Now, I often will ask questions like this on tests and things like that. And so you want to find the number of people who
Professor
read at
Bradley,
least.
we can't
Yes.
see the question.
Oh, that's not good. Okay, so whoever was saying that, that was good, and that you were
I'm
telling
probably
me
not
that.
I'm good for audio, but I'm probably not the best for visuals because I get distracted easily.
Okay, and that may have been Madeline. So anyway, what I have to do is, this will be a temporary problem just because the reason this is screwed up like this is because we're remote. Okay, now soon you will be looking at whoever was saying that. Thank you for calling my hand on that. And I'm going here, and now you should be able to see what I was reading before. Okay, you guys can read, I don't have to read to you. So I'm going to ask you to read, to solve parts A, B, and C, and I will give you 5 minutes to do that, and then we'll review the answer. You really should try this because that's going to help you understand this. You want to draw Venn diagrams, which is something I want to emphasize during our discussion today. So everybody got 5 minutes now to do this. Okay, if you solved it, congratulations. If not, we'll look at a solution. Okay, so here is an approach to this. Now, you didn't have to use exactly the same nomenclature, but here I guess that was Newsweek, and F was a magazine and T was another magazine, and they can overlap in these ways. And you might notice for each of these circles, you can either be in or out, and that means it is 2 times 2 times 2, which is 8. So there are 8 regions that are here, and so you have to use the information to find out how you fill all of these things out. So you start filling these out based on the information given, and you find there are 20 people that are outside, and each of these 8 disjoint regions end up with those numbers. So those are the numbers you should come up with. But in part A, we want to find what was the union of all of these. And so one way you had to use, you could do this, is by using what is called the inclusion-exclusion principle, which means if you're talking about the number of things in union T union F, you throw in everything, the numbers that are in T, and F, but then you have to subtract off the pairwise intersections, and then you actually subtracted off the pairwise intersection too many times, so you have to add this in. And so that's a theorem you're supposed to know, things like that. If we take all of our numbers, we plug it in, and we find that the answer to A is 100. All of these numbers were talked about. And down here, the answer to part C is 56. Okay, so I'm going to count to 5, Mississippi, in case anybody wants to ask any questions about this.
Professor,
Yes.
for the first problem, do we have to write out all the union and intersection notations, or can we just show the answer like through the numbers that we got?
Well, if I gave you, well, it depends, okay? Part B in the problem said fill out a Venn diagram. You didn't have to write all of it out, but you would have had to, I mean, to answer part B the way it was written, you would have to show me a picture that looks like the thing that's labeled B at the upper right of this of this screen.
Right.
Okay, to answer B. Now, if I didn't ask you to do that, you might have to do that anyway to answer your question. But if I just ask you A and C, then you know, I didn't ask you to do that, so you could have done it another way. I hope I answered your question.
Yeah, you did. Thanks.
Okay. All right. Let's move on then. Determine the power set of, and here you have a set that is A, B, C, and D. Now the power set is the set of all subsets of something. And again, I do expect you to know that terminology. I define these things in the, in the videos and in your books. So you want to know what the power set is. The power set is all the subsets that you can have of this. Now, one of the things that is really key, and I'm just going to speak to this again, a way I like to do it. You see each of these elements, A, B, C, and D, can either be in a subset or not in a subset. Well, if they're all not in a subset, you have a set that doesn't have anything in it, and so it is the empty set. And because the if part, it being false, means that the implication is true, the empty set is in fact a subset of any set. So you see, to talk about the power set of A, you're going to have a set of sets, and you're going to have the null set there, and the rest of these are going to be, so you have the set A, which has 4 elements in it. Sometimes that's called an improper set. Then you have sets with 3 elements in it, and there's a handful of those you can have. Then you have all the sets with 2 elements in it and 1 element in it, and then finally zeros in it. Now, if you say, well, there are 4 elements, and each of these in turn could have been in or out, you could say, well, there's 2 states of nature times 2 states of nature times 2 states of nature, and that's 2 times 2 times 2 times 2, and that will be 16. And generalizing this, what is true is if you had a set with n elements, there would be 2 raised to the nth power number of subsets for that. Okay, So let's look at the next one. My point with this next problem was I did want you to understand what a partition is, and this is listing all the possible partitions that can exist here. And you see what a partition is you take a set and you break it into disjoint chunks. Now that means that the union of them have to be the entire set. And that also means that let's see, how do I want to say that? It also and they have to be disjoint. Now, so that means that each partition of S can contain either one element, or two elements, or three elements, or four distinct elements. So if you look at 1, 2, 3, and 4, you list all the partitions that you get. So you see there are several partitions that you get. In fact, for this, there are 15 different partitions of S. Now, when we're talking about graph theory and things like that, or just in general set theory, we are going to be talking about partitions. So this is an important terminology thing for you to know about. Here it was talking about a proof, but I think we've talked about enough proofs. Actually, not enough proofs, but we talked about enough set proofs. So what I'm going to do for the balance of the period is I'm going to talk about some induction proofs. I think these are different examples than what I did in the videos, and I'm not 100% sure, but these are probably different examples than are in your book too. So I am going to talk about 154, and this was the little dominoes theorem that I was talking about, where you use the principle of math induction to prove these. So we're going to prove that this one, 154, we're going to prove that this is true by math induction. And when we're proving this is true for math induction, we're showing this is true for every n that's an element of the natural numbers. Okay, so now we're going through the proof of this. So you may want to, I don't know, if you're taking notes or something, you might want to write that down or something. But anyway, we'll go here. Okay, now here is the proof, and I just wrote this up and then I faxed it to myself and put it in here. So you see, the first thing is you have to show that one of the dominoes topples, and in fact, we have to show that P of 1 is true. Now, if I take n equal 1, in that formula, what I really have to show is that 1 over 1 times 5 is equal to 1 over 5. And that's true. And that meant that the first domino topples. Now, if you don't show that this is true, you haven't done the problem. So this is a critical thing. And just continuing the analogy with dominoes, if you don't knock over a domino, they're all still standing. So, you have to knock over a first domino, and so that has to be true. That's an important part of your proof. And then you do what is called the induction hypothesis. And this is the analogy is you're making the dominoes close enough to one another, so if you trip over the nth one, it will knock over the very next one in the sequence. So we make what is known as the induction hypothesis, and we assume something is true. So we assume that P of K is true. And again, I'm using K here instead of N because it would be confusing if I had too many N's floating about. Okay, so I assume that P of K is true. Now, I'm going to write down what that means because it's worth writing this down. And I haven't written your tests or anything like that, but I might even ask you questions about what is step 1? What is your induction hypothesis? I could ask you. So your induction hypothesis is we're going to assume that P of K is true. That means that 1 times 5 plus 5 times 9 plus 9 times 13 plus ... so on and so forth, all up to 1 over 4k minus 3 times 4k plus 1 equal k over 4k plus 1. We're assuming that that is true. Now, what you have to show is if you assume that is true, that will knock over the next domino, and the next domino has to be pk plus 1 has to be true. So we have to show that is true. So this is a heart of the proof. And again, there's two steps in this proof. The first step is showing that that a domino topples, so it's true for something. And then you have to show, and if the pk is true, that forces pk plus 1 to be true. So we have to, or at least what I'm choosing to do here, is write down what we have to show. So we must show, and it is 1 times 5 plus 1 over, it is 1 over 1 times 5 plus 1 over 5 times 9 plus so on and so forth. But I have to go all the way up to 4k plus 1 minus 3, because you see this is p of k plus 1 times 4k plus 1 plus 1, and then I have to put k plus 1 everywhere I had k. So I have to show that is true. Now here's the way the proof's going to go then. So I'm going to start with this side right here, and I'm calling that the left-hand side. I will often use LHS to stand for left-hand side. So we'll start with the left-hand side, and we have to show that by calculation or otherwise that the left-hand side is equal to the right-hand side. So we start with the left-hand side, and that's going to be on the next chart. So this is at least a 2-page proof. So what I have written here across the top line is the entire left-hand side, but I did add an additional thing just to help us think about things, and this is a key to the proof, because what I know is by my induction hypothesis, this stuff that I'm putting these little braces around, and I'm calling that the induction hypothesis, that this is k over 4k plus 1. So I have activated the induction hypothesis in this step. And I'm also going to do a little bit of algebra here, because if I expand this last term, and so I will have 4k plus 4 minus 3, that's really 4k plus 1. And 4 times k plus 1 is 4k plus 4 plus 1 is 4k plus 5. So this is what I am adding to that after I've done that. So I did two things here. I did my induction hypothesis and I did some algebra, and I got this. But now I need to add these guys together. And so to add these guys together, I have to get a common denominator. So here I have 4k plus 1, there's a 4k plus 1, but on this one I have a factor of 4k plus 5. So I have to multiply top and bottom by 4k plus 5. And so what I'm doing is I'm multiplying by 4k plus 5 over here. So I get k times 4k plus 5. Over here I have 1, and the common denominator is this. Now I have to keep going, and I'm going downward, not across. So if I multiply all this business together, I get 4k squared plus 5k plus 1 all over 4k plus 1 times 4k plus 5. But that numerator factors, and this is a common factor that I can cancel from numerator and denominator. So what I have is k plus 1 over 4k plus 5. Now that's almost what I need, and this is what I get after I cancel those common factors. But then to really show the proof, and I have to go back and look at what I had to prove, but I had to show that this is k plus 1 all over 4, and this is times k plus 1 plus 1, but that's certainly what 4k plus 5 is. So you would have to show all of this work in order to prove this. But then what would have happened is I will have shown that if I assume p of k is true, that forces pk plus 1 to be true. Therefore, by the principle of mathematical induction, that statement that I started with is true for all n in the natural numbers. Now I'm going to, now this is really something fundamental, because we're going to be doing induction in graph theory. We do induction all over the place in this course. Is a very powerful technique. Now, it doesn't tell you what the theorem is. You have to figure that out some other way. But if you think something is a theorem, it does provide you a very powerful way to prove it for all n an element of the natural numbers. So I am going to count to 10 Mississippi in case people have questions about this proof. And then I have another example, maybe even 2 examples to do. I am always mindful of your time though, so I know we only have a little bit of time left, but I do want to see if there's any questions on this. So I am counting to 10 Mississippi. Okay, so that is good. Let's go to a different problem. And the different problem that I'm going to do is, I'm trying to think of which one I want to do first. I guess it is 55. I know I didn't circle it, but I'm going to do 55 first. I also did 56, but let's do 55 because I think it's a little cuter. Okay, so we're doing 55. So we're to prove that 7 to the nth power minus 2 to the nth power is divisible by 5 for all n an element of the natural numbers. So I jump to here. That's not where I want to be. Hold on. Okay, yeah, here it is. This is the one I want. Okay, now, all right, so we're going to use induction for this. So we have to show that P of 1 is true. So we let the exponent be 1, and we say, well, yeah, that's 5 times 1, so that is divisible by 5. And then we make an induction hypothesis. Now, in this case, the induction hypothesis says we're going to assume that P of K is true. So if we assume P of K is true, that means we're assuming that 7 to the k power minus 2 to the k power is equal to 5 times some constant. That means where C1 is an element of the natural numbers. And so that means that we're assuming that's true for 7 to the k power. And that means that 5 divides that. Now, what we have to show is, and I am writing what we have to show that 7, or we have to show that P of k plus 1 is true. So that is 7 to the k plus 1 minus 2 to the k plus 1 is equal to 5 times some other constant, where the other constant is also an element of the natural numbers, and that means that 5 divides into here. And just going back to a question before, yes, you want to know what it means to say something divides, and this is what it means. Okay, so now I'm going to start with then my left-hand side of what I have to prove. And I'm going to start doing a calculation. So here I'm going to start with the left-hand side, this business here, and this is 7 to the k plus 1 minus 2 to the k plus 1. And now I do something cute here. Now, sometimes students, when I do something cute, they say, how did you know to do that? Well, I've studied a lot of math in my life, and this is tradecraft. And I can't even remember who taught me this, but it might have been a great math teacher who I had when I was young, named Andrei de Corvin. I think I've told you about him. He was born in Russia, but was raised in Paris. And I, for a long time, I thought he was not, I didn't know he was Russian. I thought he was French. But anyway, he may have taught me this tradecraft, but you're learning it here. And there are some very powerful techniques in mathematics. One is adding 1 in a clever way, or excuse me, multiplying by 1 in a clever way, and sometimes it's very clever. And another thing is we can add 0 in a clever way. Here I'm adding 0 in a clever way. Now I'm doing it here, so you've seen the tradecraft, you should know, oh, this might be something I try. Proofs are not easy. But okay, so this is 7 to the k plus 1. So 7 times 7 to the k is 7 to the k plus 1. And then I have minus 7 times 2 to the k. But then over here, I'm adding 7 times 2 to the k. So you see, I'm adding 0 in a clever way. And over here, I have 2 to the k times minus 2, which is that. So you see, what I've done is I've rewritten this, adding 0 in a clever way. But you see, now I can use my induction hypothesis on this one, because 7 to the k minus 2 to the k is 5 times C1. And 7 minus 2 is 5, so we have that. Now I can factor the 5 out of here, and I do that down here. And when I factor the 5 out of there, I have 5 times the whole of 7c1 plus 2 to the k. Now this is an integer, and so I could call this c2, and that means that this is divisible by c2, and I have finished my proof. And so I'm going to count to 10 Mississippi in case anybody wants to ask a question about this. Okay, I hit 10 Mississippi, which is fine. I did post this in your syllabus tab just this and the other slide. This is the things that were due for February the 7th, and I'm really changing it to February the 8th because we don't meet on the 7th. And I'd rather people just brought them to class. And here we don't meet on the 14th, we meet on the 15th, so I'm changing that. So just, you know, realize that that's what we're going to have. And okay, I already talked about this one before, but it's posted there. I haven't talked about this one before, but this is a problem using math induction. And so what we have is, this is an LSA, and this is talking about the Fibonacci sequence. I'm waving at a colleague here, so I'm probably going to pant a little bit. And so here's what the Fibonacci sequence is. The nth term is the sum of the previous two, and except for the getting started F1 and F2, and you're supposed to use math induction to prove this formula. Now, please understand that I am asking you to use math induction to prove this. So if you do some other thing with fancy generating functions and stuff like that, that's cool that you know about that stuff, but that's not what I ask you to do. So please follow my directions. That's really it. I'm going to stop sharing, and I'm going to stop the, let's see, I know I need to go back to this, and I'm going to stop the recording, and I'm dismissing you guys.